In this tutorial, we're going to talk about Faraday's law. Imagine, for instance, that we have a ferromagnetic bar, and then we provide, for instance, a source of voltage with a resistor, and we have, for instance, a coil or a solenoid or whatever that is in this situation, right? That is here. And of course it will provide current, right? And the fact that this guy provides current will, for instance, generate a magnetic field in this into this ferromagnetic bar. This we know from previous situation. Now let's put, for instance, another situation where we have, for instance, another coil, right? And we put a voltage. Now, the fact, for instance, that this magnetic field was, for instance, produced, generates in this guy a very, very small lecture, which is very rapid. And that's Faraday's law. If this guy has a resistance, then there will be, for instance, a current induced or a voltage which is induced due to the change in this magnetic field. So Faraday saw this situation and then he accounted for this phenomena. Faraday's law states per se that change in voltage, which is going to be induced, is going to be given by, there is a minus sign, and we're going to explain that minus sign with Lenz's law later on in another video. N being, for instance, the number of turns, which has, for instance, the coil, times a change in the magnetic flux with respect to time. So this will tell us that if there is a change in magnetic flux, then there is going to be a voltage induced. And of course, you can divide this, for instance, over the resistance, right? Over the resistance, and then you can have, for instance, the current which is induced in this situation. That's because there is Ohm's law, right? But that voltage induced is due to the change in magnetic flux. Remember that magnetic flux was, for instance, B dot A times, which is, for instance, the magnitude of the magnetic field times the magnitude of the transverse area in the coil times the cosine of the angle between both of them. And in this sense, we can see the derivative, and the derivative of this magnetic flux with respect to time, well, we have three terms, and those three terms, they can change. We can have, for instance, the term where A and cosine of theta remain constant, and then we have the change in magnetic field due to time. That's what happened in the first example, right? We generated, for instance, a change in the magnetic field in the surroundings of the yellow circuit, and that's the reason why there was an induced voltage. Well, it could be, for instance, another option, which we're going to be studying as well, where you have the magnetic field, and then of course you have the cosine of the angle, and there is a change in the area with respect to time, a change in the area of the loop. So the loop can change its area, and then it will induce the voltage as well. And for instance, there is another, and these two, for instance, have a minus sign because we are talking about the minus, right? We have a minus sign there. We have a minus sign here, right? And of course, all of these can be times the number of turns, right? And then we have the third, which we have B and A, but we have, for instance, the derivative of the cosine of theta, and the derivative of the cosine of theta, well, you know, is the minus sine of theta, that's the reason for this plus, times the derivative of theta with respect to time, right? times the derivative of theta with respect to time, which for instance that is the angular velocity, that's omega, that's the angular velocity. So this might actually be happening, that the theta or the angle between B and A is changing because this guy is, for instance, rotating. So this is Faraday's law of induction, and we're talking that there is going to be an induced voltage or an induced potential, an induced voltage, due to a change in any given parameter, for instance, the magnetic field, the area, or the angle between the magnetic field and the area, right? And that could generate an induced current. That is Faraday's law. We call it of induction.